Hello learners, welcome to Dr. D.Y. Patil Vidyapith's Center for Online Learning. I am Professor Dattatray Katore and you are studying with me Statistics and Quantitative Techniques. So we are going to learn Unit 2 of this course which is Measures of Central Tendency. In this video, we are going to learn Introduction to the Measures of Central Tendency, the meaning of central tendency. Then there are various measures of central tendency such as mean. Then there are various types of mean such as combined mean, weighted mean, harmonic mean, geometric mean. Then we will be discussing what is median and mode. So we will be understanding how to calculate these measures of central tendency for group data as well as ungrouped data, for discrete data also. So we have studied frequency distribution in previous unit, and we know that what is grouped frequency distribution and what is ungrouped frequency distribution and what is discrete data. So we are going to use the concept which we have learned in the previous unit. Introduction. In statistics, a central tendency is a central value or a typical value for probability distribution. Now let us keep aside for some time probability distribution because presently we haven't studied probability distribution, but what we can understand from this particular sentence is that central tendency is central value of the numerical distribution or numerical data. It is occasionally called an average or just the center of distribution. So when we have data and when we try to find out the center of that data, a central means a single representative value which will be centrally located either geometrically or by some mathematical method is the measure of central tendency. The most common measure of central tendency are the arithmetic mean, median and mode. So these are the most common measures of central tendency. Measures of central tendency are defined for a population, large set of observation of a similar nature. Now what is a population? Population is the totality of the items which are under consideration of the survey or investigation, and a sample is a representative portion of the population. So measures of central tendency are calculated for population as well as sample. Measures of central tendency continued. A measure of central tendency is a single value that attempts to describe a set of data by identifying the central position within that set of data. So as already discussed, central tendency is a single value that can represent the entire data set. Alright, so it can be centrally located. As such, measures of central tendency are sometimes called as measures of central location. So as the measures of central tendency are located centrally, therefore the measures of central tendency are called as measures of central location sometimes. The mean, median and mode are all valid measures of central tendency, but under different conditions. So there are different conditions under which we should use mean, median and mode. Some measures of central tendency become more appropriate to use than others in certain situations. Let us discuss some of the definitions of measures of central tendency. Simpson and Kapka defines measures of central tendency as a measure of central tendency is a typical value around which other figures are gathered. Waugh has expressed an average stand for the whole group of which it forms a part yet represents the whole. An average stand for the whole group means a single value, a value which stands for the entire group, which can represent the entire group of which it forms a part yet represents the whole. So it forms the part but represents the entire data set. In layman's term, a measure of central tendency is an average. It is a single value, single numerical value we can say, which can be considered typical in a set of data as a whole. So it is basically a single value that can represent the entire data set. So it is the value which defines the characteristics of entire data set. So instead of understanding individual numbers, we can have a single data set, single value which can represent the entire data set, and which will show the characteristics of the entire population or sample under study. So that is what measure of central tendency. Importance of central tendency. To find a representative value, so we know that we cannot judge, or we cannot make any conclusion from the data set, because there may be numerous values in a data set, numerical data, and therefore we are interested to find out a single value which will represent the entire data set, and therefore the measure of central tendency are very handy in finding the representative value which will represent the entire data set. To make more concise data, so to make the data more concise, we can use the measures of central tendency. To make comparison, so we can compare the mean or any other measure of central tendency of one group of data with other group of data. It is helpful in further statistical analysis. So measures of central tendency are useful in other statistical analysis also. Now the first measure of central tendency is arithmetic mean. So mean or arithmetic mean is also called as mean. So mean or arithmetic mean refers to the sum of all the variables divided by the number of variables. So it is the most popular technique of finding out the average of values. So it is also referred to as the arithmetic mean or average in a day-to-day life. Now let me take the pointer so that I can explain it. Suppose we have values x1, x2, x3. These are variables, values of variable. So x1, x2, x3, x4 up to xn. So these are the values of which we have to find out arithmetic mean. So how do we find out? Let us again go through this definition. Mean or arithmetic mean refers to sum of all the variables divided by the number of variables. So sum of all the variables, so arithmetic mean, it is denoted by x bar, generally x bar, which is equal to, what is the numerator? Sum of all the variables. So it is sum of all the variables, x1 plus x2 plus x3 plus dot dot plus up to xn. Right, so this is addition of sum of all the variables, and this is divided by number of variables. So in this case, how many variables we have? x1, x2, x3, 3, 4, n variables are there. So we can write n here. So sum of all the variables, n variables, divided by the number of variables. So this is how we get the x bar value, that is arithmetic mean. So this can be written as x bar is equal to, now this addition x1 plus x2 plus x3 plus up to xn is written as summation of xi, where I is running from 1 to n. So summation of all x such as x1, x2, x3 up to xn can be written as summation of this particular notation is called as summation. So summation of xi, where I is running from 1 to n, and this is divided by n. So this is the formula which we use to calculate the arithmetic mean. So the mean of a set of values or represent measurement is the sum of all measurements divided by the number of measurements in the data set. The mean is the most popular and widely used. It is sometimes called as arithmetic mean. So most popular measure of central tendency, and the arithmetic mean is commonly called as mean. So this is how we calculate it. So for example, we have data such as 3, 7, 9, 10, 12. So we are interested in finding out the mean of these numbers. So how do we calculate? X bar mean is equal to what? Addition of all these variables. So 3 plus 7 plus 9 plus 10 plus 12 divided by how many variables, how many numbers are there? 1, 2, 3, 4, 5. So divided by 5. So this will give us 3 plus 7 is 10, 10 plus 9 is 19, 19 plus 10 is 29. 29 plus 2 is 31 plus 10 is 41. 41 divided by 5. So we know that 5 8s are 40, and this will be 5 2s are 10. So 8.2 is the average or mean of these 5 numbers. So instead of representing or instead of writing all these numbers, we can write down that the mean of these numbers is 8.2. So let us calculate the mean for ungrouped data. So for ungrouped data, arithmetic mean may be calculated by applying any of the following methods. So we have some methods here: direct method and shortcut methods. So again, mean for ungrouped data. So if we get the mean of the sample, we call it the sample mean, and it is denoted by x bar. Yes, the sample mean is denoted by x bar. Now we know that what is sample and what is population. So population is the total number of items which are under investigations, but many times it happens that that population is very large, and that's why we cannot observe or study each and every element in the population. That's why we take representative samples from the entire population. These are the portion of the population. So instead of studying entire population, we study samples of the population. So sample mean is denoted by x bar, and the population mean is denoted by mu. So this particular notation is called as mu. So the population mean is denoted by mu, and sample mean is denoted by x bar. So we compute the mean of population, we call it the parametric or population mean. So this is the parameter and this is the statistic denoted by mu. So we have the formula stands same for population mean as well as sample mean. So sample mean is equal to sum of all the values in the sample divided by number of values in the sample, and population mean is equal to sum of all the values in the population divided by number of values in the population. Direct method. So how do we calculate the mean? So it is calculated by using following formula. So with this particular formula which we have already discussed, so we know that when there are values such as x1, x2, x3, we have already discussed this particular formula. So when we have x1, x2, x3 up to xn, and we are interested in finding out the arithmetic mean of these numbers, then how do we find out? X bar. So the mean is denoted by x bar. So this is equal to summation of all x, summation of all these variables divided by the number of variables n. So where x bar is equal to arithmetic mean of the population, n is the total number of observations in the population, and summation of x is the sum of all the observations. Example is given here. So we have already discussed one example. Still we will discuss this. A sample of 5 executives received the following bonus last year. So it is in dollar. So $14,000, $1,000 it is in. So $14,000, $15,000, $17,000, $16,000, and $15,000. So these are the bonus received by 5 executives. So x bar is equal to summation of x divided by n. So summation of x, we have to add all these values. So 14 plus 15 plus 17 plus 16 plus 15 divided by how many values are there? So 5 values are there. So the denominator is 5. This is equal to, so now addition of all these, 14 plus 15 is 29, 29 plus 7 is 36 plus 46, 46, 52, 62, and 67, and 10 is 77. So 77 is the addition of all these 5 values divided by the number of values 5. So this is equal to 15.4. So this is how we calculate the arithmetic mean for ungrouped data. So find out we have one more example here. So find out the arithmetic mean of the following observation: 10, 15, 37, 42, 79, and 83. Now I leave it up to you to calculate arithmetic mean for these ungrouped data. So because we have already solved 2 examples on this. Shortcut method. So in this case of shortcut method, the concept of arbitrary mean is followed. So in this method, we assume a particular value from the data set as an arbitrary mean, and by using that value we calculate the arithmetic mean. So in the shortcut method, what do? We assume a particular value from the data set itself as an arbitrary mean. The formula for calculation of the arithmetic mean by the shortcut method is given by x bar is equal to a plus summation of d divided by n, where this a is the arbitrary mean or the assumed mean, d is the deviation from arbitrary mean and assumed mean. So d is equal to x minus a, and n is the total number of observations in the population. So we are going to calculate the arithmetic mean by using this particular formula. So let me take pointer once again. Yes, so the formula for calculation of the arithmetic mean is given here. So we have firms here, right? A, B, C, D, E, F, G, 7 firms are there, and their import quantities are given here: 27, 32, 34, 39, 56, 62 and 70. Now we have to calculate the arithmetic mean of these import values by using shortcut method. So what do? We assume any value in this particular observations data set as the arbitrary mean or assume mean. So here we assume 39 is the arbitrary mean. So after assuming it, we take deviations d. Look at the formula. What we need summation of d, we need n, we need a. Now we have assumed 39 as the arbitrary mean, so the value of a is 39. How many companies, how many firms are there? 7 firms are there. So n's value of n is also available. Now what we need? D. So d is x minus a. So x are the input values and a is the assumed mean. So 27 minus assumed mean is 39. So 27 minus 39 is minus 12. 32 minus 39 is minus 7. 34 minus 39 is minus 5. 39 minus 39 is 0. 56 minus 39 is 17. 62 minus 39 is 23. 70 minus 39 is equal to 31. So we subtract 39, that is assumed mean, from all the individual x values, and we get deviations of x values from arbitrary mean. So what do we do with this deviation? Look at the formula again. So this is the denominator. So summation of d. So addition of deviations. So minus 12 minus 7 minus 5, 0 plus 17 plus 23 plus 31 gives us 47. So 47 is the addition of all the deviation. Now let us put all these values in this particular formula. So x bar, this is x bar is equal to assumed mean 39 plus summation of deviation is 47. So summation of deviation is 47 divided by number of observations 7. So this is equal to 39 plus this will be 7 6 are 42, 7 7s are 49. So 7 6 are 42, 5 is the remainder. So 6 7s are 7 are 49. So 6.7 this will be. So 39 plus 6.7. So this will be equal to 45.7. So this is the value of arithmetic mean by shortcut method. Here it is. The exact value is 45.71. So 39 was the assumed mean, then summation of deviation was 47 divided by 7. So this will be equal to rupees 45.71. Again we have shortcut method. To data of imports of certain firms for the year 2010 are mentioned in the following table. From the above data, calculate the average value of the imports of these firms using shortcut method. So you can now solve this. Is this the same problem we have already solved, say 27, 32, 34? Yes, this is the same problem. So the answer of this particular problem is 45.71. Let us move ahead. So arithmetic mean calculated by direct method we have studied now. Now we are going to calculate the arithmetic mean for group data. So far we studied how to calculate arithmetic mean for ungrouped data by using shortcut method as well as normal method, and now we are going to study the arithmetic mean calculations for group data. So by direct there are also various methods for group data. So direct method, shortcut method and step deviation method. So by direct method, x bar is equal to summation of fx. You can call it fx instead of m. So I am writing it here. So x bar is equal to summation of fx. F is the frequency which we get from the frequency distribution table. You know it very well now, and divided by n. So n is the total number of observation, and when we have frequency distribution, this n is equal to summation of f. Then shortcut method, again we use the arbitrary mean or the assumed mean, and then we calculate summation of fd, where d is the deviation of individual x values from a and n is the total number of observation. Again we have step deviation method. So a plus a summation of fd dash, it is fd dash divided by n. So deviation divided by class width we take here instead of deviation. So we take step deviation. So here this particular deviation d is equal to x minus a, that is individual x values minus assumed mean, and in case of d dash, that is in case of step deviation, we use d dash is equal to x minus a divided by I, where I is the class width. So you can use h instead of I also. In some books or in some references, class width is denoted by h also. So in the case of direct method, the following formula is used. So in case of direct method, we have x bar is equal to summation of fx divided by n. X bar is the arithmetic mean, f is the frequency, this sigma stands for summation, x is the number of x is the individual observations, and n is the number of observations. So we have classes now because this is a frequency data. So the following table gives the marks of 58 students in statistics. Calculate the average marks of this group. So marks groups are mentioned here, 0 to 10, 10 to 20, because this is a group data. It means that in this particular group 0 to 10 there are 4 students. In the range of 10 to 20 marks there are 8 students. 11 students got marks in the range of 20 to 30. So like this. So this is the grouped frequency distribution. So from this data we have to calculate the arithmetic mean. So the formula which we use here is x bar is equal to, if you remember it, let me write it here again, x bar is equal to summation of fx, direct method, divided by n, where n is summation of f. So these are the frequencies. Number of students or number of occurrences in the particular group are called as frequencies. So these are the frequencies, 4, 8, 11, these are frequencies. So summation of frequency is equal to n. So addition of these frequencies is also given here, 58. So we have got the value of n, because we know that for frequency distribution n is equal to summation of f. Now what else we need? Summation of fx, summation of multiplication of f and x. So these are f values, but what is x value? Because we have classes here instead of individual x values. So what we do, we take mid values as x value, right? So 0 to 10, the mid value, the midpoint of this particular class is 5. How do we get it? 10 plus 0 divided by 2. Then 10 plus 20 divided by 2 is 15. So that is the mid value of 10 to 20. The mid value for this is 25, 35, 45, this will be 55 and 65. So these are all x values. These are f values. What we need in the denominator, look at the formula, we need summation of fx divided by n. So multiplication of frequency and x values, and then we have to add them. So fx we will calculate here, fx. So 5 4s are, so this is x value, this is corresponding frequency. So 5 4s are 20, 15 8s are 120, 25 11s are 250 and 25, 275. Then 35 multiplied by 15, so this will be equal to 350 plus 175, 450, 525. Then 45 multiplied by 12, so 450 plus 90, this will be 540. Then 55 multiplied by 6, so 50 multiplied by 6 is 300, so this will be 330. And 65 multiplied by 2 is 130. So this is how we can calculate fx. And once we calculate fx, look at the formula again. So we need summation of fx. So these are fx values, multiplication of f and x, and summation of fx will be the addition of all these fx values. So I think the problem is solved on the next slide. So let us check it. Yes. So this summation of fx is equal to 1940. So this summation of fx is equal to 1940. So this is 1940. Alright. Now what we do, let us put all these values in this particular equation. So summation of fx is 1940. divided by the number of observations. So number of observations is equal to summation of frequency 58. So this will give us the arithmetic mean by direct method for group data or frequency distribution, and this is equal to 33.45. So here we have marks in the form of classes. So we calculated midpoint of these classes. After calculating the midpoint, we have frequencies here. So we multiplied frequencies by the midpoint. So 5 4s are 20, 15 8s are 120, and so on. The addition of all these fx values is calculated, which is 1940, and this is divided by the number of observations. So 1940 divided by 58, and this is equal to 33.45, which is the arithmetic mean of this data. Now one thing which must be noted here is that the 33.45, this particular value, arithmetic mean value, always lie between these two values. This particular value should always lie between 0 and 70. So it cannot be less than 0 and cannot be greater than 70. Then shortcut method for group data. So in the case of shortcut method, the concept of arbitrary mean is followed. The formula for calculation of the arithmetic mean by the shortcut method is given below. So where a, now this is the formula, x bar is equal to a plus summation of fd. So instead of x we use d here, deviation, and divided by n. So a is the arbitrary or assumed mean, f is the frequency, d is the deviation of arbitrary mean or assumed mean, that is d is equal to x minus a. So when the values are extremely large and or in fractions, the use of direct method would be very cumbersome, and therefore we use the shortcut method. This is because the calculation work in the shortcut method is considerably reduced. So we have an example here. So we have classes, again the same example is continued, and yes, so we have to solve this particular problem by using the shortcut method. So again we have to calculate, let me check the pointer once again. So we have to calculate the midpoint values, which are denoted by x. So 0 to 10, the midpoint is 5. How do we calculate? Upper limit divided by upper limit or upper boundary plus lower boundary divided by 2. So 10 plus 0 divided by 2, 20 plus 10 divided by 2. So this is 15, 25, 35, 45, 55, and 65. So these are x values. So now what do we use? D, we use d, deviation is equal to x minus a. So we can use any particular value as the assumed mean. So for example 35. So deviation here will be 5 minus 35 will be equal to minus 30. 15 minus 35 will be equal to minus 20. 25 minus 35 will be equal to minus 10. 35 minus 35 is 0. Then 45 minus 35, this is equal to 10. This is 20, and this will be 30. Alright. So this is how we do it. The calculations are shown here also. So we have marks 0 to 10, these are the classes. We calculate midpoints, and 35 is the assumed mean. So frequencies are given here, and then we calculate deviations from the assumed mean. So deviations are like 5 minus 35, which is minus 30. 15 minus 35 is minus 20. 25 minus 35 is minus 10. 35 minus 35 is 0. 45 minus 35 is 10, and so on. So this is how we calculate deviations. And what we do, look at the formula once again. What we use, what formula we use is x bar is equal to a plus summation of fd divided by n. Alright. So deviations are calculated, frequencies are given here. So we multiply frequencies by deviation. Look at here. So frequencies are multiplied by deviation. So this is the formula. Okay. So this is the formula. So we use this deviation. So we have to, what we have to do, look at the formula. We need multiplication of frequency and deviation, and then we have to sum them. So fd, so these are the deviations which we have already calculated. These are the frequency values. So 4 multiplied by minus 30 will be equal to minus 20. 8 multiplied by minus 20 is minus 160, and so on. So this is how we get all the FD values. Addition of this all the FD values is equal to minus 90. Now let us put all these values in this particular formula. A is the assumed mean, which is 35. Here it is. This is the assumed mean about which we have calculated deviations, 35. Then summation of FD. Summation of FD is equal to minus 90, and this is divided by n, that is number of observations, which is equal to 58. So 35 plus minus 90 divided by 58, and this is equal to 33.45. Now note that the value of arithmetic mean we got by direct method as well as by shortcut method are same. Then we have step deviation method for group data. So following formula will be used for calculating arithmetic mean for step deviation. The only difference in shortcut method and step deviation is that the d value here we use is nothing but deviation divided by the class size, the class width we can say. So x minus a divided by I. So this is what we do in case of step deviation. Otherwise there is no difference. So the same formula or the same example is continued, and this is the formula we use. This is d dash, instead of d you can call it d dash. So these are the marks in classes. Let me check the pointer. Yes. So these are the marks. These are midpoint values of these classes. Then frequency, which was already given. Then deviation. Now this is not deviation. This is step deviation, d dash. So d dash is equal to x minus a divided by I. So x minus a is the assumed mean divided by a. So let us assume 35 as the assumed mean, right? Arbitrary mean. So 5 minus 35 is equal to, so 5 minus I will do one calculation here. So 5 minus 35 is minus 30 divided by I is the class width or class size. So how do we get the class size? 10 minus 0, 20 minus 10, 30 minus 20. So 10 in each case. Right. So minus 30 divided by 10, this is equal to minus 3. So this is how we can calculate step deviation for all the values. So these are the step deviation values, and once we get step deviation values, we have to calculate FD dash. So this is FD dash. So frequencies multiplied by step deviation. So 4 multiplied by minus 3 is equal to minus 12. 8 multiplied by minus 2 is equal to minus 16, and so on. So this is how we calculate all FD dash values. Now look at the formula. What we need, we have arbitrary value of mean, that is arbitrary mean or assumed mean. Then we need summation of FD. So what we have to do, we have to add all these summation of all these FD values, FD dash values. So summation of FD dash is equal to minus 9. So minus 12, minus 16, minus 11, 0, 12, 12, 6. Addition of all these values equal to minus 9. So let us put all these values here. So we know that assumed mean is 35 plus minus 9 multiplied by 10. Summation of FD is given here. So this is not actually FD. So this is I value. This I value. Let me put it here. Assumed mean is equal to 35, which we have assumed already. Summation of FD is minus 9. This is divided by the number of observation. Number of observation is equal to summation of frequency, which is equal to 58. So 58, and this particular value is multiplied by I. So what is I? I is the class width. Class width is 10. So this effect x minus a divided by I is nullified by multiplying this particular value by 10, or that is I. So this will give us 33.45. So again we got the same value which we got by using direct method as well as the shortcut method. Then arithmetic mean for discrete series. Now what is a discrete series? Here the classes will not be given, only individual values will be given and their frequencies will be given. So this is called a discrete series. So in case of direct method, the following formula is used. X bar is equal to summation of fx divided by n, the same formula. So all the notations remain same. So shortcut method, so in case of shortcut method, following formula is used. X bar is equal to a plus summation of fd plus divided by n. So this is direct method for discrete data, and this is shortcut method for discrete data. So we have one example here. So here the classes are not given, marks are given and the number of students are given, right? So there are 10 students who got 5 marks, there are 20 students who have got 15 marks, and so on. So this is the discrete data. So solution is given, x bar is equal to summation of fx divided by n. So this is direct method. So what do we do in this case? These are x values. Let me take the pointer once again. These are x values and this is frequency. Frequency is the number of occurrences for a particular observation. So what we need in the formula, we need summation of fx in the numerator, and this is divided by n. So n is the summation of frequency, we can say. So fx values we can calculate. 10 5s are 50, then 15 multiplied by 20, this is equal to 15 2s are 30, 300. Then 25 3s are 75, so this will be equal to 750. 35 5s are 175, 0. 45 4s are 180 and a 0, and 55 3s are 165 and a 0. So these are fx values, and we need summation of fx in the numerator, and summation of frequency is the n. So we know that n is equal to summation of f for the frequency data. So 10 plus 20 is 30, 30 plus 30 is 60, 60 plus 50 is 110, 110 plus 40 is 150, 150 plus 30 is 180. So 180 is the addition of frequency, which is n, right? So this is how we can calculate summation of fx, addition of all these values divided by 180. So this must have been solved on the next slide. So here it is. Summation of fx is 6300 divided by 180, and this is equal to 35. So the arithmetic mean for discrete data, here the classes are not given. So for this kind of data, the arithmetic mean is 35. So from the following data, calculate the arithmetic mean. So this is the same problem here again. I skip it. Yes, this is assume method, the same problem. So here we have formula x bar is equal to a plus summation of fd divided by n, where a is the assumed mean or arbitrary mean. So we have to solve this particular problem, and here is the solution. So marks are given, discrete marks, frequency is given, 40 is the assumed mean. So we calculate deviations about assumed mean. So 10 minus 40 is so 5 minus 40 is minus 35. Then 15 minus 40 is minus 25. 25 minus 40 is minus, okay, this is not actually the assumed mean. Let me check once again. So 40 minus 5 is minus 35, 40 minus 25, 15 is minus 25, 14 minus 25 is minus 15, 40 minus 35 is minus 5. Yes, 35 minus 40 is minus 5, 45 minus 40 is 5, and 55 minus 40 is 15. So 40 is the assumed mean. You can take any value, the calculation doesn't change. So these values we got deviation values. So deviation is multiplied by frequency fd. So 10 multiplied by minus 35 is minus 350, 20 multiplied by minus 25 is minus 500, and so on. So we got all these fd values. Summation of all these fd values is equal to minus 900. Now let us put all these values here in this particular formula. So assumed mean is 40, right? Let me write the formula. X bar is equal to a plus a minus or a plus summation of fd divided by n. So a is the assumed mean 40, summation of fd is minus 900, and n is the number of observations, which is equal to summation of frequency. So 40 minus 900 divided by 80, 180. So we know that 0 0 got cancelled, 18 5s are 90. So 40 minus 5 is 35 marks. Arithmetic mean for group data in case of less than series. So from the following data, calculate arithmetic mean by direct method. So we have marks less than 10, 20, 30, 40, 50, 60. In case of less than series is given here. So it means that there are 10 number of students who got less than 10 marks. There are 20 students who got less than 20 marks. There are 30 students who got less than 30 marks, and so on. So first of all, we need to convert these less than frequency into some classes. less than this number into some classes. So we know that 10 students got less than 10 marks. So the first class will be equal to 0 to 10. So as the first class is 0 to 10, second class will be equal to 10 to 20, 20 to 30, 30 to 40, and so on. The frequencies will remain same here, 10, 20, 30, 50, 40 and 30. And then we calculate the arithmetic mean by direct method for this frequency distribution. X bar is equal to summation of fx divided by n. Now I will not explain this because this kind of problem is already solved. So marks, midpoint is calculated, frequency is already given, midpoint multiplied by frequency will give you fx. Summation of fx is here, so summation of fx divided by n is the addition of all frequencies. So 6300 divided by 180, this is equal to 35. Then arithmetic mean for in case of more than series. So more than series means there are 10 students who got more than 0 marks, there are 20 students who got more than 10 marks, there are 30 students who got more than 20 marks. So like this. Now we need to convert this data into again classes. So marks, the first class will be 0 to 10, second will be 10 to 20 and so on, and these are the number of students. So we got the same problem. Once we solve it by using the direct method, we get the same result, that is 35 as the arithmetic mean. Arithmetic mean for group data in case of inclusive series. So 1 to 10, 11 to 20, 21 to 30, these are the inclusive type of classes where both the class boundaries or class limits are included, right? So 11, 20, then 21 to 30, 31 to 40. So these are not continuous classes, there is a gap of 1, right? So this is the problem. And how do we do it? So we convert the class limits into class boundaries. And how do we convert? We have already studied in the unit 1 how to convert the class limits into class boundaries. So these are class limits 1 to 10. These are inclusive type of classes. We have to convert them into exclusive type of classes called as class boundaries. So what do we do? There is a difference of 1 between 10 and 11, and then we distribute that difference of 1 between the lower limit and upper limit. Alright, so 1 minus 0.5 and this will be 10 plus 0.5. So 0.5 to 10.5 like this. So 0.5 to 10.5 and so on. So these are the classes. And then we calculate the midpoint values. Then we have frequencies already given. This is the deviation. Actually it is step deviation, x minus a divided by a. Let me write it again. Yes. So this is x minus a divided by I. X minus a divided by I. So this is the assumed mean 45.5. So x minus a, so this is x value 5.5. Alright, so let me do one calculation for you. 5.5 minus assumed mean 45.5 divided by class width. Class width is the difference between these two values. 10.5 minus 0.5 is 10. So 5.5 minus 45.5 will be equal to minus 40, and this is divided by 10, this is equal to minus 4. So this is how we get all the step deviations. Then we multiply the step deviations by the frequencies, that is fd dash. So 10 multiplied by minus 4 is minus 40, 20 multiplied by minus 3 is minus 60, and so on. We get all the fd dash. Then we calculate summation of fd dash, which is equal to 180 minus 180, and then we put all these values in this particular equation formula, a plus summation of fd dash divided by n multiplied by I. This is step deviation method. So a is the assumed mean, which is 45.5, right, and this fd dash is equal to minus 180, this I is equal to 10, and n is the total number of observations, which is 180, and by solving this we get x bar is equal to 35.5. Then there is something called as weighted mean. Weighted mean is the mean of a set of values wherein each value or measurement has different weight or different degree of importance. So there are some observations, and they assume different degrees of importance, and according to them we have to assign some weights to the observation. According to the importance they assume, we have to assign some weight to the observations. So this is called as weighted mean. X bar is equal to summation of xw divided by summation of w, where this w is the weight assigned to particular observation, x is the individual observation, x bar is the weighted mean. So W1, x1, x2, x3, these are the various observations, and W1, W2, W3 up to Wn, these are the weights assigned to individual observations according to their importance. This is divided by all the summation of all the weights, that is W1, W2, W3 up to Wn. So summation x bar W, that is weighted mean, is equal to summation of Wx divided by summation of W. So we have a formula, we have an example here. Marks obtained are given here: 38, 36, 15, 20 and 55 on different parameters. In class test, marks obtained are 38, in presentation 36, in attendance 15, class participation 20 and final examination. But the invigilator or the examiner considers that the final examination should be given more weightage, more importance, and that's why out of 100, now you calculate this: 60 plus 10 is 70, 70 plus this 20 is 90, plus 10 is 100. So out of 100, a weightage of 60 is given to the final examination, a weightage of 10 is given to the class participation, that of 5 is given to the attendance. For presentation, importance is 15% only, and for class test, importance is 10%. Now what we do, how do we calculate it? So these are the different importance weights assigned to the individual observations according to their importance. So let us calculate this. So x bar W is equal to summation of Wx divided by summation of W. So we have W here, summation of W is equal to 100, right? And what we need to calculate, Wx values. So let us calculate Wx values. 38 multiplied by 380, yes. 36 multiplied by 15 will be 360 and 180, 540. 15 multiplied by 5 is 75. 20 tens are 200. 55 multiplied by 60. So 55 threes are 165. 165, 330. 330 and a 0, right? So these are Wx values. Summation of Wx will be our numerator, all right, and this is divided by summation of W. This must have been solved on the next slide. Let us check. Yes. So summation of Wx is equal to 4495, 380, 540, 75, 200 and 300 and 3300. This is equal to addition of all these values is equal to 4495. Addition of all the weights is equal to 100. So we put all these values in this particular equation. So summation of Wx 4495 divided by summation of W, which is 100, and this is equal to 44.95. So 44.95 is the weighted mean of all these values. So one thing we must remember that this particular value 44.95 is always between the smallest value and the largest value. So the smallest value is 15 here, and the largest value is 55. So it cannot be less than 15 and cannot be greater than 55. Then we have combined mean. If the arithmetic mean and the number of observations of two or more related groups are known, we can calculate the combined mean or the arithmetic mean of these groups. The combined mean formula is summation x12. This is equal to x1 bar, x2 bar. These are the various x bar values, that is arithmetic mean values for the different data sets, and n1, n2, n3, these are the number of observations in each group, right? So this is how we calculate the combined mean. So here we have an example. The mean marks of 60 students in section A. So we have different groups of students, right? So in the mean marks of 60 students in section A is 40, and the mean marks of 40 students in section B is 45. Find the combined mean. So this is the formula, right? The same formula is written here. For this is for the n number of observation, and this particular formula is for only 2 observations. So x bar 1 2, that is combined mean of section 1 and section 2, where this x1 bar is the mean of section 1. So in section 1 there are 60 students, and in section 2 there are 40 students, right? So x1 bar is the mean of section 1 students, and x2 bar is the mean marks of the section B students. Alright, so n1 is the number of students in the section 1, n2 is the number of students in the section B. So 60 is the number of student, right? 60 students in section A is 40. Mean marks of 60 students in section A is 40. So 60 multiplied by 40 plus the mean marks of 40 students in section B is 45. So 40 multiplied by 45 divided by n1. N1 is the number of students in the section 1 and n2 is the number of students in the section B. So this will give us 42 marks. So this is how we calculate the combined mean. Characteristics of arithmetic mean. Some of the important characteristics of the arithmetic mean are given here. The sum of the deviations of the individual items from the arithmetic mean is always equal to 0. So when we have some observations and once we have calculated the arithmetic mean, and if we take deviations of all the observations about the arithmetic mean and then we add them, we get 0. The sum of the squares of deviations of individual items from the sum of the squares of deviations of the individual items from the arithmetic mean is minimum, is always minimum, right? So this is summation of x minus x bar bracket square. So summation of squared deviation. So this is x minus x bar is the deviation, square of it is the square deviation. So summation of squared deviation about the mean is always minimum. So this particular value is always minimum. As the arithmetic mean is based on all the items in the series, a change in the value of any item will lead to change in the value of the arithmetic mean. So we know that arithmetic mean is based upon all the observation in a data set, and if one of the value in the data set changes, the arithmetic mean also changes. So in case of highly skewed distribution, the arithmetic mean may be distorted on account of 5 items with extreme values. So weighted, here we have one more example of weighted mean, so which we already discussed. So I will leave it to for you for the practice work. Alright. So now one thing we must understand about arithmetic mean is that when we multiply each and every observation in the data set by a value k, the arithmetic mean also is multiple of k. I will explain this. Suppose x1, x2, x3, these are the 3 values. The arithmetic mean of these 3 values is equal to x1 plus x3 plus x2 plus x3 divided by the number of observations 3. Now if I multiply all these values x1, x2, x3 by a value k, right, then this value will become a k, kx3, kx1, kx2, kx3, and therefore this arithmetic mean also become kx bar. Right. So if we multiply any observation in the data set by a particular value k, we need to multiply the arithmetic mean by that value. Right. So that will be the equation. So if we divide each and every observations from the data set by a particular value k, then again the arithmetic mean we get is equal to x bar divided by k. Similarly, if we add any number to every observation in the data set, then we have to add the same value in order to get in the same value to the old x bar value to get the new x bar value, right? So this is how, these are the characteristics of arithmetic mean. So median is what divides the scores in the distribution into 2 equal parts. So median is the geometric location or the central value when we arrange the data in ascending or descending order. So when we arrange the data in ascending or descending order, the middle value is the median. So 50% values lies below the median and 50% values lies above the median. So because median is a positional average, so it is the central value when we arrange the data in ascending or descending order, so that 50% of the observations will be less than median and 50% of the observations will be more than median. It is also known as the middle score or the 50th percentile. The median is also called as middle score or the 50th percentile. The median is denoted by MD, is the middle value of the sample when the data are ranked in order according to size. So when we rank the data or arrange the data in ascending or descending order, the middle value is median. Katore has defined the median as the median is that value of the variable which divides the group into two equal parts. So median is the value which divides the group into two equal parts, one part comprising of all values greater than and all the other all values less than median, and the other group contains all the values less than median. So for ungrouped data, the median is calculated by using this particular formula. Median is equal to size of n plus 1 divided by tooth item, and for group data we have median is equal to L1, which is the lower limit of the median class, plus n by 2, that is number of observations divided by 2, minus cumulative frequency divided by frequency multiplied by class width. We are going to learn how to calculate it. So median for ungrouped data is given here. So arrange the scores from lowest to highest or highest to lowest. Determine the most. These are the steps involved in calculation of median for ungrouped data. First of all, we need to arrange the data from lowest to highest or highest to lowest. So we have to arrange the data, the numerical data, in ascending order or descending order. And in the second step, what we have to do, determine the middlemost score in the distribution. If n is the odd number, that is if n, that is the number of observation, is an odd number, and we get the average of two middlemost scores if n is an even number. Find the median score of 7 students in a class. So here look at this particular graphic. Median, when n is odd, what do we do? Median is equal to n plus 1 divided by tooth observation, and when n, that is number of observation, is an even number, median is equal to n plus tooth plus n plus tooth 2 plus 1 divided by 2. So this is how we get the median. So find the median score from the 7 students in the English class. So these are, we have 7 values here: 19, 17, 16, 15, 10, 5 and 2. So these values are already arranged in descending order, right? So 19 is the highest, then 17, then 16, 15, 10, 5 and 2. So this data is already arranged in descending order, and therefore we can pick the central value, that is the middle value, which is 15 in this case, and this is our median. So this is this is odd data. The number of observation is an odd number. So what do we do? So let me calculate it here. So in case when the number of observation is an odd number, we use this particular formula, n plus 1 divided by 2. So here n is the number of observation 7 plus 1 divided by 2. So this is the position of median. So 8 divided by 2, this is equal to 4th observation. So first, second, third and fourth. So this is the 4th observation, which is median. So the same, okay, find the median score of 8 students in an English class. So these are the scores of 8 students for English course. So 30, 19, 17, 16, 15, 10, 5 and 2. Now this is the number of observations in this case is an even number, right? So what we do, yes, so the median value is equal to 16 plus 15. So how do we get it? Okay, let me tell you. This is 8 observations are there. So what we do, we directly calculate n by 2. This is the position of median. So n is the number of observation, n is equal to 8 and divided by 2. So 4th observation. Okay, so there are 8 observations. So the middle 2 observations are 16 and 15, right? So there are 2 observations here, 16 and 15. So what we have to do, we have to take the average, the mean of 16 and 15, which is 15.5. Or directly you can use this particular formula, n by 2th observation plus n by 2 plus 1th observation divided by 2. So n by 2th observation is 4th, n by 2th observation is the 4th observation. Let me do it here. And n plus 1 by 2th observation, here it is, n plus 1, yes, n by 2 plus 1th observation. Okay, so what we can do here, we take average of both values, n by 2th observation plus n by 2 plus 1th observation and average of this, right? Now n by 2th observation is 4th observation, and the 4th observation is 1st, 2nd, 3rd and 4th observation is 16. Then n plus 2 plus 1th observation, so n by 2 plus 1th observation, so n by 2 is 4, 4 plus 1 is 5, 5th observation, so 5th observation is 15, so we take 15 here, and the average of this is equal to 15.5. So this is how we calculate the median for individual data for even number of observations. So for group data, median is equal to L plus H divided by F. This is multiplied by this particular bracket, n by 2 divided minus C. So L is the lower limit, H is the class width, F is the frequency of median class, n is the total number of observation, and C is the cumulative frequency of preceding median class. So we have data here. So marks 0 to 4, 5 to 9, 10 to 14, 15 to 19, 20 to 24, and the number of students are given 2, 8, 14, 15, 14, 17, 9, and the addition of number of students is 50, and less than cumulative frequency is already given. If it is not given, we have to calculate it. So yes, this particular problem is not solved, so I will solve it for you. So what we will do, again, first of all we will write the formula. Median for group data is equal to L plus H by F, n by 2 minus C. So this is the formula. L is the median class. So first of all we need to calculate this particular number, n by 2. So n is 50. So n by 2 is equal to 50 by 2, which is 25th. Alright. Now we have to look for a number which is just greater than 25 in less than cumulative frequency. Alright. What we have to do? We have to look for a number in this particular value which is just smaller than the median, which is just smaller than this particular 25 value. So 24 is the smaller value, and therefore the median class is 10 to 14. So the lower limit of this is the median class. The lower limit of median class is 10 plus H is the class width. So difference between lower limit and upper limit, 14 minus 10 is 4. F is the frequency of median class. So frequency of median class is 14. N upon 2, which is 25, and C is the cumulative frequency of a class preceding to median class. So cumulative frequency of a class preceding to median class is 10. So this will be equal to 10 plus 4 divided by 14 multiplied by 25 minus 10 is 15. So this will be equal to 10 plus 15 4s are 60 divided by 14, and this will be equal to, median is equal to 10 plus 60 divided by 14. So 10 plus 14 4s are 56, 4 is the remainder, 14 2s are 28. So this is equal to 14.2. So the median is 14.2. So this is how we calculate median. Mode. The mode denoted by MO is the value which occurs most frequently in a set of measurement or values. In other words, it is the most popular value in a given data set. Croxton and Cowden define it as the mode of the distribution is the value at the point armed with the item tend to most heavily concentrated. It may be regarded as the most typical of a series of value. So when we have data, and then the mode will be the most frequently occurring number in a data set. The number which occurs or appears most frequently, most number of times in a data set is mode. So in a crash test, 11 cars were tested to determine what impact speed was required to obtain minimal bumper damage. Find the mode of the speeds given in miles per hour below. So these are the miles per hour speeds given, and what we have to do, we have to calculate the mode for this particular data. Ordering the data from least to greatest. Now this is not compulsory, this is optional. You can directly look at this number and find out a number which appears most number of times here, but ordering the data will help you to understand how many occurrences are there. So the smallest number is 15, then the next smallest number is 18. 18 appears 3 times, 18, 18, 18. Then the next smallest is 20. 20 appears only once. Then 22, 24, 24, 24, 26 and 26. So here from this data we can understand that 18 appears 3 number of times, and also 24 appears 3 number of times. So this particular data set has two modes, that is 18 and 24, and therefore this data is called as bimodal, right? Because there are two modes values, and therefore it is called as bimodal. Then a mode for grouped frequency distribution. So M0, which is mode, this is equal to L. L is the lower limit of the modal class. F1 is the frequency of modal class. F0 is the frequency of a previous class to modal class. Then F1 is again frequency of the modal class, previous class, then class after the modal class, and H is the class width. So find the modal class and the actual mode of the data. So these are the frequency values. So from the frequency values itself we have to judge the modal class. So the class which has highest frequency is the modal class. So in this case this is the highest frequency, and therefore the class 16 to 18 is the modal class. Now let us put all these values in the formula which we have seen on the previous slide. So mode is equal to L plus in bracket F1 minus F0 divided by twice F1 minus F0 minus F2, and this is multiplied by H. Let me check it once again. Yes. So L is the lower limit of modal class. Now modal class is the class with highest frequency, so 8, and this is the modal class. So lower limit of this particular class is 16, so 16 I write here, plus F1. F1 is the frequency of modal class, that is, this is F1, 8, minus F0 is the frequency of a class previous to modal class, so this will be F0, so 2, twice F1 is 2 multiplied by 8, minus F0 is 2. F2 is the frequency of a class next to modal class, which is 1. This is F2, so this is 1, and this is multiplied by the class width. The class width in all the cases is 18 minus 16 is 2, 15 minus 13 is 2, so class width is 2. So 16 plus 8 minus 2 is 6, 8 2s are 16 minus 3, 13 multiplied by 2, so this is equal to 16 plus 6 2s are 12 divided by 13, so 16 plus 12 divided by 13 will be 0.9 something, so 16.9 is the mode value for the grouped frequency distribution. Advantages of mode. So mode is readily comprehensible and easy to calculate. We know that by looking at the observations we can find out which number occurs most number of times, and by knowing that we can find out the mode value. It is the best representative of the data. So mode is considered as best representative of the data as it appears most number of times in the data set. It is not affected by extreme values. So we know that the mean is affected by extreme values because the mean is based upon all the observations in a data set. Now the mode is not based upon all the observations in a data set, and that's why the mode is not affected by extreme values. The value of the mode can also be determined graphically. So we can determine the value of the mode graphically. And how do we determine it? Let me show you here. We take x values on x-axis and frequencies on y-axis in order to draw a histogram, right? Histogram we have studied in the previous class. Suppose this is the histogram. So this particular class represent the highest frequency because on y-axis we have frequency. So what we do, we connect the corners of this particular bar diagonally like this, and then we take projection of this particular point, intersecting point on x-axis, and this will give us the value of mode on x-axis. So this is the graphical method of obtaining the mode value. The value of mode can be determined graphically. It is usually an actual value of an important part of the series. So it is the actual value, means the value actually present there in the data set. Advantages of mode. It is not based upon all the disadvantages of mode. The mode is not based upon all the observations. It doesn't take into consideration the observations. It is not capable of further mathematical manipulation, as the mode is not based upon all the observation. It is not capable for using for further mathematical calculations and manipulations. Mode is affected to a great extent by sampling fluctuations. So because of sampling fluctuations, mode value is affected. Choice of grouping has great influence on the value of the mode. Median. Advantages of median. Median can be calculated in all distributions. So this is one of the important advantage. It can be calculated for all the distributions. Median can be understood even by common people. So common people can understand median. Median is the positional average which lies at the center of all the data when the data is arranged in ascending or descending order. Median can be ascertained even with the extreme items. So even if the extreme items are there in the observation, still we can ascertain the value of the median. It can be located graphically. So when we arrange the data in ascending or descending order, the middle observation is median. Also let me tell you the graphical method of obtaining the median. When we draw ogives, so this is greater than ogive, this is less than ogive. So here we have an intersecting point, and when we take draw a perpendicular from this particular point on x-axis, the value we obtain on the x-axis is the graphical value of median. It is most useful dealing with qualitative data. So it is useful for qualitative data also. Disadvantages of median. It is not based upon all the observation. It is not capable of further mathematical treatment because it is not based upon all the observations. It is affected by fluctuations of sampling. So sampling fluctuations affect the median value, and in case of even number of values, it may not the value from the data. So when there are even number of observations, what we do, we take average of middle two observations in order to find out the median. So that value is not there in the data itself. Properties of mode. It is used when you want to find the value which occurs most often. It is quick and approximation of the average. It is an inspection average. So by merely looking at the observation, we can find out the mean mode. It is the most unreliable among the three measures of central tendency because its value is undefined in some observations. Properties of mean. Mean can be calculated for any set of numerical data, so it always exists. So it can be calculated for any set of data mathematically. A set of numerical data has one and only one mean. So there is only one mean. In case of one example, we have seen that there are two mode values for some data set. So that particular data set is called as bimodal. But in case of mean, there is no such two values exist for any data set. Mean is the most reliable measure of central tendency since it takes into account all the observations in a data set. It is greatly affected by extreme or deviant values, outliers. So if there are extreme values, then these extreme values affect the value of the mean. The mean is used only if the data are interval or ratio scale. So mean can be used if the data are interval or ratio scale. Relation between the measures of central tendency. So in symmetrical distribution, the mean, median and mode are equal. Symmetric distribution means the distribution of this nature, right? This is called as symmetric distribution. So this is the central line. So these two parts are equal or similar or mirror image of each other. So this is symmetric distribution, and in case of this symmetric distribution, the values of mean, median and mode are equal. In positively skewed distribution, the mean is greater than the median. Now this is positively skewed distribution, positively skewed. So here this is the mode value, the highest frequency, right? This is x-axis. So the median lies in between and there is mean. So this is x bar, this is MO and this is MD. So if x bar, this is the number line, x-axis can be considered as number line where the larger values are on the right hand side and the values decreases on the left hand side. So when x bar is greater than the mode value, then such a distribution is called as positively skewed distribution. Positively skewed distribution. And when for such kind of data, this is the mode value and there will be mean like this. So x bar value is less than the mode value, and therefore such kind of data is called as negatively skewed distribution. Conclusion. A measure of central tendency is a measure that tells us whether the middle of a bunch of data lies. Mean is the most common measure of central tendency. It is simply the sum of numbers divided by the number of numbers in the data set, and this is also called as average popularly. Median is the number present in the middle when the numbers are set in some order, ascending or descending order. If the numbers of numbers in a data set is an even number, the median is the mean of the two middle numbers, and mode is the value that occurs most number of times in a data set. So that's all about measures of central tendency. We have discussed all the three measures of central tendency such as mean, median and mode. We have discussed properties, merits, demerits of all these measures of central tendency. So I hope you have understood the measures of central tendency. Thank you so much for watching this video.